All right, really big deal starting today. We're finally going to be able to start answering the questions. You know, if someone has a new pill and they say it's going to work on everybody, how do they know? How do they know it's going to work for everybody like they say it's going to? Or even more, you know, with the times right now, how do they know who's going to be the next president before the election happens? I know some of you have learned in your government class, you've got like 1,300 people they're asking, how do they do that and how does that work? What's the mathematical theory behind it? That's where we're going, and we start with that today. All right, 4 big things that this chapter is going to address. The first two, the difference between what's called an observational study and an experiment. An observational study. Now, an observational study will help you find association. Remember from our pictures, the dotted line meant there's an association between the explanatory and the response. So one goes up, the other goes up. Number of cavities and reading level. Okay, an observational study is the perfect thing to do if you're trying to find some sort of an association between 2 variables. Okay, and what the bottom line is you just go out and observe what is already happening. Many observational studies are done on smoking. People go and choose to smoke, and then we see how much cancer, or what the rate of cancer is for those people. Now the problem with an observational study is, yeah, we do find an association. We have a higher cancer rate with people who smoke, but there could be some lurking variables, right? Their lifestyle and other things. Okay, but there's been many observational studies done on smoking. Those people in the malls with the clipboards, you know, they're just walking up to you. They want some information, your age, and, you know, what stores you like to shop in, or things like that. Once again, they're observing. They're just seeing what you already do. There is no attempt to do anything to you. They're just observing what's happening. Now, with an experiment, it's through an experimental design, a good experimental design. Remember, it's got randomization, replication, control. But through an experimental design, we can actually find out what that underlying cause is. Only through an experimental design. And what's the huge difference? In an experiment, you actually do something to the person. You impose a treatment on the person. When you're in college, never, ever, ever volunteer yourself to be a part of a psychological experiment. I was broke. I didn't have any money. I think they offered like $5. That's all I got. But I went and took place in a psychological experiment. They did something to me. I still, in the middle of the night, will wake up and twitch. It started after they did the psychological experiment to me. Okay? Never volunteer. They will mess you up for your entire life. I don't care how much money they give you. But they did an experiment on me. Okay? They imposed a treatment on me. And remember how we talking about how there's never been an experiment done on smoking? Because you'd have to make that person smoke. Okay? So in experimental design, okay, a treatment is being imposed on the subject. Me as the experimenter doing something. Observational study, I just observe what you're doing all by yourself. Okay, often it's impractical, or you can't do an experiment or a simulation, or an observational study. We can do something called a simulation, where we can actually do real-life events, and we're going to use the random digits in the back of your book to do it. Okay, so we'll be talking about a simulation a little bit later in the chapter as well. And then the big deal, what are we trying to do here? We're trying to predict the future. We're trying to predict who's going to win the election in 3 days. We're trying to predict what this pill is going to do to you. Is it going to do what it says it's going to do without any side effects? So through this, we hope to get at statistical inference. So when you hear the word inference, it's about predicting. All right, a bunch of vocabulary and a bunch of different things that we have to learn here. Number 1, population. Now you're going to answer some questions about identify the population, identify the sample. What I need you to understand is when you get the population, you get the entire group, but you have to understand what the question's about. For example, let's say I'm trying to figure out the average miles per gallon of 1970 automobiles. Well, the population of interest then is all 1970 cars. That's the population of interest. Not every car that's ever been made. It's just 1970s cars. Or if I'm trying to figure out what the average grade was for yesterday's test, My population of interest isn't everybody at this school or all students. It's just the 140 so AP Stats students from yesterday. That's the population of interest. But if I get everybody, if I'm trying to figure out the average grade of the 140 tests, I would take all 140 of those tests, figure out the average. That's called the population, when I get them all. A sample is when I take a part of that population, a subset, 30 or 40 or 1,300 if I'm looking at voters. Okay, so a sample is a subset of that population. All right, here's the big deal. We're going to talk about the difference between a census and sampling, and which is better. All right, a census is when you actually go out and contact everyone in the population and then do whatever mathematical manipulation you need to do, average test grade or whatever. But you go get everybody. That's referred to as a census. Sampling is when you take a sample from that population and infer the results from that sample. So I get a sample of people, 1,300 likely voters, and I infer who's going to win the election based on that sample. So my question to you is, which is more accurate? Which is going to give you more accurate information in order to do your inferencing?
Census.
Yeah, you get them all, right?
Yeah.
You got everybody. So you get everybody and you do some data analysis, it's going to be more accurate. I'm going to argue with you it's not. I'm going to make an argument to you right now that says, no, taking a sample and using that sample to infer for the population will actually give you more accurate results. Is anybody with me? Does anybody want to give some examples on, I mean, how could that possibly be more accurate?
Like, if you're talking census data with large enough populations, like the entire United States, there's going to be some errors if you're working with a small
Think about this now. A tremendous amount of data. Is there a chance that the people collecting the data might make some mistakes? Absolutely. Okay. Whereas if I'm only taking a little sample, I have less chance to make errors when I'm looking at a smaller amount of data. Anybody else? I like that one. Anything else that maybe a sampling might give us more accurate results?
Like if you're counting inventory, people are not going to always count carefully, but if you just take a sample of it?
No, but the question is, why is taking a sample more accurate than actually doing a census?
Well, because the census is like the entire thing, but if there's too much to count, then sometimes you miss it or you...
Might not even count it. Here's the deal. Every 10 years, our country has to do what's called a census. Every 10 years, everyone in this country has to be counted. So let me tell you how this goes. This is the year 2000. I forget this. So I get this big envelope. Man, it's a huge envelope in the mail. It was the census information. I was supposed to go into that envelope and fill out all this information and send it back. Now you would think this would be the most exciting thing for a statistics teacher to do, right? Provide data for somebody. I didn't do it. It was big and I was tired. I threw it away. So about a week later, there's a knock at my door. And I don't know, you guys probably made me mad that day or something. I was in a bad mood. So I get to the door, and there's this little lady, nice old lady. She's got glasses on, and she's got a thing, and she's there to count. She's there to do the census. Because I'm with the Census Bureau. Can I ask you a few questions? I shut the door in her face. I didn't even say no. I feel bad. I didn't even say no. I just shut the door in her face. I was like, bad mood or something. You guys can understand it. Kind of felt bad about it, but well, you're not counting me. Week later, same nice little old lady. She's got this guy standing behind her too. I did it again. So did I get counted? Now, do you think I'm the only one who didn't get counted? There are people in this country hiding, aren't they? Right? And there's homeless that don't even have a door to knock on. So do you think for a second that census that we're doing is anywhere close to right? Do you think that census is anywhere close to an accurate count of the number of people in our country? I don't think so. Now, every 10 years, the argument takes place in Congress. Because there are those who believe that if I took good samples, now you'd be way smarter than me to figure out how you would do the sampling, but you would go to a certain area, a smaller area, you'd count the people in that area, and you'd find other areas like it, and you'd build the population that way. There are many that feel that would be a much more accurate count of how many people are in the country than the actual censuses. I agree. I think they're right. Okay, but there's a lot of people that don't believe that. So, I mean, I'm not saying, you believe what you want, but I really believe sampling will actually get you a more accurate answer than taking the entire census. And this is a big deal. Okay, how are you going to take your sample? How are you going to do it? And you, as in your upcoming homeworks and your tests, you're going to go into great detail of exactly how you're going to take that sample. And the reason is we want to avoid something called a bias. You need to understand the definition here and be able to recite it. A bias is a systematic favoring of one outcome over another. Let me give you an example. Let's say I'm standing outside of the Republican convention. And people are walking out, and I ask them, who are you voting for? I don't care if I get 1,300 or 13,000 or 13 million. I got a horrible sample. Why? It's kind of biased, right? Am I not systematically favoring the Republican candidate in that situation? Okay, so please remember the precise definition for bias is when you make a selection, you choose a sample, and it has a systematic favoring of one outcome over another. Now, I'm going to give you a couple of examples. I think I have about 9 of them, so I got about 6 or 7 more of them to give you on Monday. But these are 2 types of biases. You've got to be able to read a situation and identify what kind of bias could be there. All right, the first one is called voluntary response bias. Never trust any predictions, conclusion, inferences that come from a study when someone actually works hard and gets into your study or experiment. Let me give you an example. Those like radio talk shows, right? People call in to give their opinion. Well, what if they're trying to do some sort of who's going to win the next election thing or something? And they take their results from a radio talk show call in? I mean, think about this for a second. The person's got to take the time, dial the phone, wait, make their vote. Is this the typical person? I've never called a radio show in my life. Okay, these are the zealots. These are the 1% on both sides that are doing stuff like that. That's not a good representation. And then what if it's like a conservative talk show? Who's going to win the next election? Romney's getting 98% of the vote. Really? Okay, so anytime someone volunteers or has to go the extra effort to be a part of it, someone last period said, well, people that return the census, aren't they volunteering? Yeah, but don't they come out and try to find you afterwards? Okay, so they have to get the votes counted. Another example of voluntary response. I went to UC Davis, so every once in a while I get a letter in the mail from them. And they want to know, what kind of job I have, how much money I'm making. Because then they make these recruiting flyers and they say the typical UC Davis graduate makes blah, blah, blah. Now, who's returning that? Yeah, Bill Gates. I bet Bill Gates sends his back every single, although I don't think he would call it, sends it back to every single time he gets it. Really rich people, right? Look how much money I make. I never send mine back. I don't make any money. Okay, so when they get the results, aren't the results biased towards a higher income? And they know that. They know that when they send that out. Okay? So whenever you see something, in the news, latest study says, the first question you ask, how did you get your sample? Where did that sample come from? What was your design? All right, finally, the last one is called convenience bias. Convenience bias is when you take the easiest way possible to go get your sample. Standing outside a Republican headquarters, that's an example of convenience bias. Okay, you just stand there, it's real easy, you come to me and I record the data. Okay, those people in the mall. Okay, they go to where people are. Now, I've never been to a mall in my life, I don't think. Sometimes they go to the mall at 10 a.m. on a Tuesday. Who are they talking to? Old people. People without jobs. You can ask them how much money they make, they don't have a job. Okay, so be on the lookout. I mean, if I'm at 10 o'clock in the morning and I'm seeing how much people make, and I'm going to go to a mall to do it just because it's easy, you can't trust the answers. You can't trust because it's automatically biased. In this case, it's going to be I'm systematically favoring those who make less.
So does that mean you can't ever obtain all your data in one sitting?
Well, you got to pass this test. You know, is it possible that you could get a good sample in one sitting? I don't know what one sitting means, though. Are you?
Well, just like you go out to the mall at a specific time.
Mm-hmm.
You know, does that mean that you have to vary things like that?
Well, it just means that you're inference. Let's say you're going to the mall at a certain time of day, and you're asking the question, you know, what stores are you visiting? Something like that. What it means is that you can only make an inference then onto people at the mall at 10 a.m. on a Tuesday. Now, if you're smarter about it, and the key thing about picking your sample is going to be randomness. That's what we're going to talk about. If you randomly pick a lot of different days and different times and bring your data in that way, you have more faith and you can infer onto different times as well. If I take a sample of voters and they're all from Ohio, I can't infer onto the whole country. If my voters all came from Ohio, I can only infer onto Ohio. Okay, so to answer your question, you might be able to get a decent sample, but you're not going to be able to infer onto much. Okay, so a lot of really important stuff that you're going to see May 10th, but we're going to be talking about all the time. Understand the difference between an observational study, okay, and what you can get from that, and what an experiment is, and what you could potentially get from that. Okay, and just remember that bias. I think you know, a better answer to your question is even like you could develop a study, you could get a sample, and maybe you didn't use a very great technique, but you still didn't have a bias in it. Okay, then potentially the sample could be okay. So remember, a bias is when you systematically favor one outcome over another.
Kind of like what Zane was saying. Is it like even is that kind of unethical to get like a completely unbiased?
Unethical? You mean impossible or unethical?
A little of both, maybe.
Okay. No, it's not impossible, and that's what we're going to learn about. How do you do that? How do they get those 1,300 people? How do you go about that? What's the only way to do it so that... Now, the results you get from those 1,300 might not be the right answer,
Yeah.
but was how you got that sample, was it biased to start with?
Yeah.
That's the difference. Okay? Any other questions, comments?
Do we ever see any like statistical data in the news, like for politics, that's actually true?
Well, yeah, I think you're going to find that there's good polls and bad polls. Okay, we're going to talk about some mistakes that polls make, but I think you're going to find that the good polls are going to get the answer right. Now, there's often that one poll will say one thing and one poll will say another. Okay, you really want to analyze who they were talking to and if there are any biases in their selection. Those are the first places you want to look. But I think we're going to find that the final polls that come in right before the election are going to be pretty darn accurate. Now, have there been mistakes made in the past? Yes, we're going to talk about a few. Okay, but today, as long as they're not biased. Yeah.
You mentioned that voluntary response is bad because there are some people who won't go out and actually do it.
It's usually the zealots that are wanting to volunteer, you know.
But my question is, isn't voting kind of that zealotry where not everyone's going to be voting?
Yeah, but that's a part of it. So when I go out and I'm doing a poll about who's going to win the next election, you often hear the poll was taken of likely voters, right? Because that's really my population of interest, right? Is my population of interest everyone over 18 years old if I'm trying to figure out who's going to win the next election? No, I think my population of interest is those likely people that are going to vote. That's who I want in my sample. Okay? Okay? Okay.